Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. I hope everybody is in good health. All right, so in this video we are going to discuss the second method to solve the second order non-homogeneous equation. All right, so if you can recall, before this we have stopped at method of undetermined coefficient. Okay, but somehow the method of undetermined coefficient has limitation, right? So if you can consider this non-homogeneous equation, okay, so before this we have seen method of undetermined coefficient, which can be used if the fx here, okay, is one of the four cases that we have before. Okay, so it only can be used if fx is polynomial, or fx is exponential, or fx is sine or cosine function, and lastly we have if fx is the combination of case 1, case 2, or case 3. Okay, so that is the limitation of the method of undetermined coefficient that we have discussed before. So now we are looking for the solution if fx here at the right hand side of your equation here is something else. Okay, for example, if it is given fx is tangent x, for example, or fx is 1 over x squared. Okay, so how do we solve this kind of problem? Okay, all right, so in this section, okay, to handle this kind of fx, it means other than four cases that we have discussed before, okay, we have the second method, which is what we have here in section 2.3.3, okay, method of variation of parameter. Okay, so in other words, this variation of parameter can handle any types of fx, including the four types of fx that we have before in method of undetermined coefficient. All right, so that is the advantage of variation of parameter. It can be used, okay, to solve any kind of fx. Okay, unlike the method of undetermined coefficient, it is limited to the four cases of fx only. Okay, so I hope everybody is clear on that. Next, we are going to see the steps, okay, that we have in variation of parameter to solve the non-homogeneous equation. All right, in the first step, okay, in the first step, we need to identify A and fx. Okay, so A is the coefficient of y double prime. So this is where is A. Okay, so we just identify. Okay, identify what is A and what is the fx, the right hand side term of our equation. And in the second method, we need to determine the homogeneous solution. We need to find the homogeneous solution. And based on this based on this homogeneous solution, we are going to choose what is the term for the y1 and what is the y2. All right. So if our YH, okay, if our YH is A exponent m1x plus B exponent m2x, okay, then y1 should be exponent m1x, and y2 should be E m2x. Okay, so this is how we choose y1 and y2. Okay, so you can see here in y1 and y2, we ignore the constant A and B. Okay, we just ignore that. So if your YH is, for example, A plus BX, A plus bx exponent m1 or m2x, then in this case, our y1 should be exponent m1x, and y2 is x exponent m1x. Okay, because you can see if you expand this bracket here, then we have two terms. The first one is A exponent m1x, and the second one is bx exponent m1x. Okay, so if we ignore the constant A and B, then this is our y1 and y2. Okay, without the constant A and B. Okay, so I hope you are clear about that. How do you choose the y1 and y2? So it is the same. If your YH is in a complex form, then we have exponent alpha x a cos beta x plus b sine beta x. Okay, so in this case, then our y1 should be, okay, so you can see if you expand the bracket here and then remove the constant, then we have exponent alpha x cos beta x to be the first term, to be your y1. And then for the y2, we have exponent alpha x sine beta x. Okay, so that is how you choose what your y1 and y2. Okay, so that is step number 2. Now we go back to step number 3. So in step number 3, we need to find the Wronskian W. Okay, find the Wronskian W. So W is given by, so you can see here, okay, how do you compute the W? W is, so you have the determinant sign here, okay, and inside the determinant sign, you have y1, you need to put y1, okay, and then y2, and at the bottom, we have y1 prime and y2 prime, okay. So based on the y1 and y2 that we have identified here, so we need to find the corresponding derivative, which is y1 prime and y2 prime. And then we compute the w. So the computation of w is actually similar to the process of finding the determinant of 2 by 2 matrix. So basically we have y1 multiply the y2 prime, and then minus with the y2 times y1 prime. So we will have our w. But in this case, the term for the w is in the form of x, not, okay, in terms of number, okay, because our y1 and y2 is in the form of x, okay. So of course our w also in the form of x. And then we move to the fourth step. Okay, so in the fourth step here, this is very important. So each one of you need to memorize these two formula. It will not be given, okay, in the test, also in the final exam. So the formula for u and v, so u is the negative of the exponent, the negative of the integral y2 times fx over a times w. Okay, so all of the elements in this u is actually taken from the previous step, y2 fx a and w. And for the v, it is the integral of y1 times fx over aw dx. All right. So I would like to highlight here the common mistake in finding the u and v. Okay, so sometimes students, okay, miss this negative sign here. So you need to be careful. Okay, the computation for u has the negative in the front, but the computation of v, it is positive. Okay, so I hope everybody, okay, can highlight that one, aware of that positive and negative. And lastly, the last step, okay, once we have solved the integral in step number 4, then our final answer y equals u times y1 plus v times y2. So that's the final answer of our solution. And okay, so in the next part, we are going to see the example. Okay, we have two examples, I think, example 15 and example 16, to illustrate okay, all the steps that we have in variation of parameter.